Now we will discuss multiple leader replica. What is multiple leader replica? So in the multiple leader replica, multiple leader can accept the write request. So here in this example, we are using two leader, leader 1 and leader 2, and these clients are making a write request to these leaders. And the sync is happening between these two leaders in the background. So this sync is not impacting to these client directly. Now where can we use this multiple leader? So first use case is the multiple data centers. So in the same example, let's assume the leader 1 is in the data center 1 and leader 2 is in the data center 2, and now this client is connecting to this data center 1. Now after some time, due to some network issue, this leader 1 is down, full data center is down. Now this client can connect to the other data center that is nearby to this client. So in this case, or in with the help of multiple leaders, we can handle data center failure also. So the next is the client offline operation. So in today's world, there are multiple apps, mobile apps or desktop app that can work in the offline mode without any internet. And when the internet comes up, then they can sync their data to the cloud storage. So same thing is happening here. So the user is using the mobile app and the also desktop app. Mobile app and desktop app storing the data in their local storage, and the data is syncing to the cloud storage. So we will discuss this conflict resolution in some time. And so what is happening, so here mobile phone and desktop both are acting as a leader here, because let's suppose user is using a calendar app, and user wanted to set a meeting at a 4 p.m. So user can do from app also, and user can do from desktop app also. So then the data is basically syncing on the cloud only. So in this way means here we are using the multi leader architecture here also. Now the next is the geographic reach. So as we discussed in the single leader architecture, the problem in the single leader architecture is the geographically expansion. So same thing is here. So let's suppose we there are three clients in the different region, North Asia and Europe, and there is only one database, and that is database is accepting the write request from local region or the from the other region. Now problem with the other region is that request coming from other region will take more time as compared to the local region request. And second problem is the due to only one leader, and one leader is a single point of failure. So if any failure happen, if request is coming from different region, then these client need to wait to come up this leader, because due to region distance, or the distance is more than, we can expect multiple network failures here. So in that way means for this client, we cannot write because due to some network issue. Now how to resolve this issue? So what we can do, we can create multiple databases in each region. So each region we have one database that will act as a leader and can accept read and write both. Now here we can see the all the local region clients making a request to their local region database. Now the sync is happening in the background, that is not impacting to the main client main request. If any issue happened in the sync request or network failure for some time, and that will be resolved after some time, then it it means it will not impacting the client main request. Now, what are the problems with the multi-leader architecture? So one is the conflict, second is the data loss during the conflict resolution. Let's discuss first what is the conflict. So let's suppose we have a two leader, leader 1, leader 2, and both the databases are having an initial value of x equal to 1 at time t0. Now there are two client, and one first client is connected to the leader 1, second is connected to leader 2. Both the clients updating the value of x at same time. So first client updating the value of x equal to 10, and second client updating the value of x equal to 20. Now these leader accepted the write request and successfully acknowledged back to the client. Now what happened if both the leaders are trying to sync with each other? So let's suppose leader 1 send a sync request to leader 2, update x where old value is equal to 1 and the new value is equal to 10. Now in this case, here leader 2 already updated the value of x equal to 20, so there is no x which having value is equal to 1, so that sync will fail. Same thing happened here. We already updated the value of x is equal to 10 in the leader 1, so leader 2 sync also will fail. So now we can say the entry happen at t1 on both the databases are conflicted entry. Now, how to resolve these conflicts? So there are multiple resolutions that we will discuss here. And so first is the synchronous write. So let's suppose in the same example we are using two leader and the initial value of x equal to 1, and client is making the write request. Client wanted to change the value of x. So this client wanted to update the value of x equal to 10, and this client wanted to update the value of x equal to 20 at the same time t1. Now we can say leader 1 will try to take a lock on the leader 2 entry. So here leader 1 is taking a lock on the x entry, and leader 1 successfully taken the lock on the x entry. So meantime the request leader 2 is basically waiting for the lock release, so leader 2 can serve for the this client 2. Now leader 1 is updating the value in the leader 2 database, and same happened here. So leader 1 also updating the value in own database also. Then leader 1 successfully acknowledging back to the client with the okay. Now what happened to this? Now we already changed, leader 1 already changed the value of x, so x value already changed, so we need to send failure to the client. So this client to need to retry again for the new value for the x. But the problem with the synchronous right here is it is working like a single leader architecture. So here we cannot get advantage of multi-leader architecture if we are using the or synchronous write or locking the entries. The next is the avoiding the conflict. So in the same example, let's suppose there are two leader 1 and leader 2, and leader 1 and leader 2 both initially having x and y both are 1. So the fundamental of this avoiding conflict is the so leader 1 will only write for the x and leader 2 will write only for y. So if request is coming for x, that will route out to leader 1. If request is coming for y, that will route out to y. So it means we are dividing the write operation on the basis of some keys. So here keys are x and y. So this client is making a request for x, that request will route to leader 1. Here client is making the request for y, and that request route to the leader 2. So this client successfully return the value on leader 1, and this client successfully return the value of y on leader 2. And then when sync is happening in the background, then leader 1 able to sync with the leader 2 for the value of x, and same for the leader 2 able to sync with the leader 1 for the value of y. So in that way we can avoid conflict in some situations. Now the next is higher number replica. So let's suppose we again we are using two leader 1 and leader 2. So from the number point of view, serial number point of view, leader 2 is greater than the leader 1, because leader 2 is using two serial number and leader 1 is using one serial number. Initially both have x equal to 1 at t0. Now this client is making a request, and both the clients are making a request to these both two leaders for the same key x at same time at t1. Now what will happen? So both leader will basically successfully responded back to the client and store the value in their local storage. Now in the sync part, how we will decide which value is will be the right one? So in that case what we will do, so leader 1 will initiate the sync call with the leader 2, update the x where old value is equal to 1 and new value is equal to 10. So here leader 2 will see, okay, the leader 2 already updated the value of x equal to 20, so leader 1 is less than is equal to leader 2 from the serial number point of view. So leader 2 will reject the sync request of leader 1, cannot change because value of x is 20 and leader number is 1. And same sync is started by leader 2 to leader 1, and leader 2 is trying to updating the value of x on the leader 1 database. So here leader 2 is is bigger as leader 2 is bigger as compared to leader 1 from the serial number point of view. So leader 1 need to accept the write request from the leader 2, and reject the previous entry of X. So here we might come up with a situation we might lose some data. So that is the another resolution to resolve the conflict. Now next is the merging the conflict or merge conflict. So in the same example, we are using two leader, leader 1 and leader 2. Here we have taken an example of for the cart, user cart. Initially for this user ID at time t0, this cart is empty. Now there are two client and for the same user, and that user is trying to add the milk at t1 time and into the cart. So leader 1 accepted the request and successfully responded back to the client. Now here at the same time the same user trying to updating the cart and trying to adding the egg in the cart, and that leader 2 also responded back to the client at same time. Now what happened when we are syncing? So leader 1 initiating the sync and leader 2 also initiated the sync. So leader 1 trying to adding the milk in the user cart in their leader 2 database. So leader 2 will merge the both the values milk and egg in the card, same done by the leader 1. Leader 1 also merge both the value milk and egg. So in that way, in some cases we can also resolve conflict using the merge conflict. Now the last one is the record conflict. So here again we have taken example of two leader 1 and leader 2, and we have added one column conflict. So and conflict will basically we will use this column to mark this entry is conflicted or not, and initial values of both the leaders are basically x equal to 1 and time t0, and there is no conflict for this entry. So let's suppose there are two clients that is making same request and for the same value x and same key basically x at time t1 same time with a different value 10 or 20. Now here what happened, so both the leader accepted the right request and successfully responded back to the client. Now what happened if leader 1 initiated the sync with the leader 2? So in that case leader 2 will persist both the values 10 comma 20 with marking this entry is a conflicted one. Same thing done by the leader 1 when leader 2 initiated the sync with the leader 1. Now what happen if this client is any client is making a read request, and we will return both the values 10 comma 20 with the conflict yes. Now here client need to resolve the conflict, and at t3 this client is asking for the get and we have returning back both the value. Now client resolve the conflict, and client at t4 this client setting the value of x equal to 10. Now we have successfully responded back to the client. Now leader 1 trying to sync with the leader 2 and updating the value of x is equal to 10 at t4, and that conflict is resolved now. Now we will discuss multiple leader replication topology. So what is the topology? Topology means the alignment of the leader for the syncing process. So first is the circular topology. In this, leaders are aligned as a circle in a circle, and all the leaders are basically passing the message to each other. So here leader 1 is passing the message to this leader is passing to this leader is passing to this. Now the problem here is basically in any if any leader is down, then the whole message flow will be interrupted. The next is the star topology. So in the star topology, so one of the leader is in the center, and that is basically working as a coordinator and sending and listening the message from the other leader. So here this leader is working as a coordinator, and the problem here is the same. If this leader is down, coordinator is down, then the whole message flow will be interrupted. The last one is the all to all topology. In this case, all the leaders are connected to each other, or all the leaders are passing the message to each other. Now the advantage of this all to all topology is basically if any leader is down, then the message flow will not be interrupted. But the problem here is the overhead. So because each leader listening the multiple messages, so then we have to do extra work for the syncing process as compared to star or the circular topology.